Welcome back to Advent of Code, day 17, and today we are flying in the sky. Finally, another flight, and hopefully we're going to be soon ending our journey. I even forgot where we are going to. And today we have some super secret satellites. They have an issue and we have to fix them. And we have this input. This is the small input that we're going to be using. So today we're focusing on day 17. We're pasting that and we want to parse that. We're going to be reusing what we usually have, except then here we're going to be splitting using a spread. We're going to be splitting a string into an array of characters. And here we need a three-dimensional data structure. So there are two ways that I can think of where we can describe a three-dimensional space. One way is to list all of the cubes that are active. So a cube that is active has the hash. And just listing that in an array, that's one option. And the other option is going to be having a map with only the active options. Actually, we could have all cubes in a map. Yeah, actually, we could have all cubes in a map. So I think we're going to do that. We're going to try to have all cubes in a map. So we're going to create our map const let's say let map is equal new map. So map is going to be something where we're going to have the key is going to be x, y, z, and the value is going to be active, inactive. And if a key isn't in the map, the default is that it's going to be inactive. So in the next steps, maybe we're going to need to improve the efficiency, because there might be just a few cubes, so the map might be sparse, which means there are just a few cubes and we don't need to keep in mind all the inactive ones. But I think it's easier to keep in mind the inactive ones. It's going to make our logic a lot simpler. So what we want to do is we want to go through several steps. How many steps do we want to go? Let's check in the end. We need 6 cycles. So we're just going to be doing a simple for loop. And max is going to be here 6. So I'm just going to be doing, like no functions, no nothing, just like plain code right away, because I'm not sure it's going to be reused. So you know what? Let's just not mind about classes and functions today. So this is the first setup. So here we need, so this is the turn here. We need 3 for loops. One is going to be a for loop for x. Here I don't know until how much I want to go. That's going to be a good question actually. So here we're going to check, we're going to need find min max for x, y, z. That's going to be our challenge here. And then here we can iterate. So let's start with that. And actually, forgot one important part. Here it's initialize the map. That's going to be what we're going to be starting with. So z is always equal to 0. So we're just going to be going through each element here. Lines that for each line. And here we want row dot for each. Oh wait, it's actually line dot for each. And here we have value. And here we're going to check const active. We're going to check if the value is equal to a hash. In that case, it is active, otherwise it is inactive. And now we can put in the map.set. And here we're going to get the ID actually. The ID, we said this is x, y, z that we concatenate with a comma. So z here is always going to be 0 because what we get at the beginning is a slice of the word. And we don't care. I think we're going to make this 0 in terms of x and y. And we're going to go from there. So here, this is going to be y, the y index. And here, this is going to be x. And actually, we have our ID here. So we set the ID to active. So using this double for loop, we are able to get the correct map. That's perfect. Now we need to find the mean, the max for x, y, and z. That's going to be interesting. And I think we're going to be checking... Let's check how it can expand to other places. Okay, so what we're going to do here, we're going to find the min, max for x, y, and z. I think we're going to need to get a list of all keys. So I think, you know what, it's always good to go back to the documentation. And in this case, we have map.keys that is giving us all the keys. So here, const keys is equal map.keys. Now we can go through each key. I think a for each would work in that case. Hope so. Because here that's in next. So maybe for off might be a better choice. Let's try for off here actually. For off key of keys. And here we're going to have let min x, and we're going to initialize everything to null. Let me just think for a second. I don't know if we initialize that to null. Yeah, I think we're going to do that. So we're going to get that several times. Min y, min z, x, y, z. And we're going to get the same for the max. That sounds good. And here we're going to check for each key. We're going to check if this is smaller than the mean. Because the best, I think we're just going to be doing that, you know what? So that we do just one loop through each key. That's, I think, is going to make things a bit faster. Otherwise, we could be using like math.min, but that's going to make us do several loops. So I think that's a bit more optimized to do this. So we say, so actually here we need to const x, y, z is equal key dot split with a comma. Oh, like that's actually, I prefer the simple quotes. And here we're going to check if x is below min x. Then actually we're going to remove these things. We're going to say min x is equal x. And I'm going to do that for each coordinates very quickly. Okay, we're good. So that wasn't really complex, but now this gives us the minimum and the maximum on each dimension, and this is what we're going to be using here, because we don't want to start x equals 0. We want to start min x minus 1. And the reason is we have this minus 1 is because this is going to be expanding. So here from the cycle 0 to the cycle 1, it stays a 3-3 grid in the z equals 0, but after another cycle it's going to expand to like yeah, it's going to expand once. So that's why here I'm always going to check -1. Although that maybe is going to make it expand a bit too much. So maybe we're going to have like some other conditions here to make sure we have the minimum x when there is at least one value that is active. But that's a small optimization that we're going to see later down the road. Here we need to check that this is below max x plus 1, and I believe we need to go until exactly this. So we're going to do a triple for loop here because we are in 3 dimensions. So let's go. So this is x and then this is y. So here when you nest for loops, the biggest mistake is to forget to change one of these variables. That can cost you a lot of debug time. This happened so many times to me that now I'm quite careful. Watch me make a mistake now. No, I think we're good. Okay, let's remove this. So now we're gonna check, we need to actually create a new map. So let's do that right away. We're gonna make a const, new state, new map. And now we need to check for each neighbors. So const neighbors. So in that case, I believe we're gonna need to create a function. That's gonna be a lot simpler. Get neighbors. And here we need a key, no, with x, y, z, and we need a map. And what do we do here? We're gonna get, I think, the list of values. Yeah, that's what we're gonna be doing. Yes, so here one more time we need a triple for loop. The little issue here is that we already have x, y, z here, so that's a bit annoying. Can I rename just this x to, let's call this I? Is it renaming? No, it's renaming just in the scope here, so we're going to be using that. So x, so I, j, and k are going to be my 3 variables, and we want to go from x minus 1 to x plus 1, y minus 1 to y plus 1, and z minus 1 to z plus 1. So basically here we go in 3 dimensions and check all neighbors for a specific point in the 3D space. We want to create an array here, const results, an empty array. We're going to push data in this, and we're going to split the array in the end. We're going to return it back to the function. So here we want to check if map.has, oh wait, we want the key here. Key is going to be, const key is going to be equal to I, j, k. Oh wait, one thing we need to make sure, because we are doing a for loop, we need to make sure if x is not, so if I is not x and j is not y, I'm going to explain in a second why I am doing this, and k is not z, we need to take this into account because we want to only get the neighbors and not the current x, y, z position. So these are the neighbors. and this is removing the current position. So here we just have to join with a comma, and here map that has key. Oops. And if map doesn't have key, then we can do result.push false. Meaning if the key isn't in the map, it means that we are outside of the bounds of the current array, and in that case we know that the state is going to be false because this is a default state. Default state, they say, yeah, I think everything starts as an inactive state. Almost all cubes start inactive except the one that we say here. So this is why this is false. And then here we have to push result.push. We have to push something here, which is map.get key. And this is going to give us true if this cube is active, and false if the cube isn't active. And oops, here I made a mistake. In that case, our getNeighbor function should be correct now, and we can use it here. Neighbors, getNeighbors, x, y, z, and map. Now we can count them. Const active neighbors. Hola, I just used two different ways to spell neighbors. Okay, that's better. This is going to be neighbors.filter. So the active one dot length. Basically, this is an array of Boolean, so doing this will just return the true values, and dot length is going to count the Boolean that are set to true. And this is going to give us the active neighbors here. And here we need to set a cube as active is exactly 2 or 3 of the neighbors are also active. Otherwise, it becomes inactive. Okay, so we're gonna check if map.get so const current, we need the current state here, and the current state is map.has we need the key. Damn it, that's quite complex. The key is x, y, z that join with a comma. Now we need to check if the map has the key. In that case, we can return map.get key. Otherwise, this is always false. Meaning, we said like if the state isn't in the map, it means that this is an inactive cube. And now we can check if current state. So if this is active and 2 or 3 are active, so if current state and let's change current state, let's gonna say is active. So if is active and active neighbors is not 2 and active neighbors is not 3, in that case we know that we need to change to inactive. So we're gonna set new state dot set key false. Otherwise, we check another option, else if. We check if a cube is inactive but 3 of its neighbors are active. So if it is inactive and exactly 3, yeah, and active neighbors is exactly 3, in that case, we push the new state to true. And otherwise, it doesn't change. So we keep the new state set to is active. That sounds like this is everything we need, except here after this for loop, we need to set the original map set to new state. This looks like it is good. I think we need to, display a bit this, because the problem is that we've used the map, so it's going to be a bit tough to display this. So I think we're just going to be logging here the map, just for starters. We're going to be doing just one turn for now. And let's go with day 17. Okay, we have 20 here. 20. Oh, this looks like this is too big for me. The first is x set to 20. This is an issue. So I think, you know what, this key.split here, we need to make sure we map that to a parse int, otherwise we're going to have some trouble. We need to make sure we have integers. That's an issue that we've seen a couple of times, and I want to make sure we are doing the right thing here. So here we're joining. When we do a join, that's not a problem, but when we do a split, this is where bad things happens. Is there other parts where we do a split? No, I think this is the only time when we do a split here. So we pass ints. Let's retry here. Okay, now you see we only have small numbers, relatively small numbers. That's good. That is good. The annoying part is that it's not very visual, right? We should be sorting in terms of Z. You know what? Everything is false here. Wait, everything is false. That is really bad. If everything is false, we know we have an issue here. So we're going to be checking this here. What we want to check here if Z is equal to 0. In that case, we want to log x, y, and active neighbors. Yeah, I think that makes sense. Let's check this out. What's up? What is up? So I would be thinking that there will be a bit less of those. Active neighbors is always set to 0. That's a bad thing. So maybe we check get neighbors instead. Everything is set to false, so we have an issue around here. Not cool. Map.getKey. You know what? I think before we do all of this, we need to check here that our input is passed correctly. So here we're going to process that exit to make sure we just run until this point. Let's check this out. We have true, that is 1, 0, 0. So this one, then next one is 2, 0, 1, 2, 2, 1. So it is this one, I believe. Wait, 2, 1 is this one, yes. Then 0, 2. Oh, let me just double check that for a second. I think I've made a bit of a mistake because here we know that this is x, y, z. So here the two first values should be, no wait, false, true, false. I think I may have made a mistake around here. X, Y, Z. So here we go through from top to bottom, and then here X. On the second line. Okay, no, that is correct. So this is the first line with y set to 0. We have just one true in the middle. This is the second line, we have one true in the end. And this is the last line, we have 3 truths. So we are good for the first one. So I think we can remove this. We have done a good parsing. Here, let's check this out. I believe we only care, the problem is that we only care y when y is set to 0. So yeah, we definitely have an issue around here in the get neighbors. Here this is x, y, z. We have x, y, and z. So that, like, the big mistake that you can do here is mixing the x's and the y's and the z's. The key here looks good, so here we're going to be logging, you know what, we're going to be logging like crazy. We're going to be logging the key and map that has key. We're going to be doing that, and that's all. Here we're going to process that exit to make sure we just run this thing. Oh, right. I can't do process that exit because this is here where the function is called get neighbors. Yeah, get neighbors. Okay, so here let me remove this, and we remove this as well. So we're going to be debugging for little bits. Okay, so here the one that we know is set to true is 0, 1, 0, 0. So we need to check 1, 0, 0. One zero zero is set to true here, so this is right. We have one value set to true, so we are good in that. Maybe everything is correct and I just didn't pay attention to the final output. So let me remove this and run everything and check the final output. Is there a true here? Let's check this out. True, next true. Looks like there is no true around here. Okay, so there is an issue, but we don't know yet what it is. So here we need to check when we are in this value 0, 0, 0. When we have 0, 0, 0, we should have at least one true, but we don't have this true, so that is annoying. So here we're going to check if x equals 0 and y equals 0 and z equals 0. In that specific case, we're going to display everything. Log key and map that has key. And here, yeah, let's do that. Even more debugging. So in that case, we know Okay, are we doing the right thing here? In 0, 0, 0, we should be checking what is this value. This value, we know this is 1, 0, 0, so we should be checking 1, 0, 0, but it looks like we are not checking 1, 0, 0. That's annoying, you know. That is annoying. So it looks like here we are checking just 1, 2, 3, 4, 5, 6, 7, 8 options, and we should be at least at a lot more options. So we have an issue in our loop around here. Let's check this. X minus 1, x plus 1, y minus 1, y plus 1, z minus 1, 1. It happens. Oh wait. That's the mistake here. Here we need to only exclude one thing when the three are exactly that. So we need to check that either this one is different, or this one is different, or this one is different. And wait. And if the three coordinates are equal, then in that case and that case only, it's not passing. Okay, so I think in that case we should have something a lot better. I've seen some true already, so we should be good. And here we have a lot more options. And let's clean up a bit. I think we should have exactly what we wanted to have. So here I wanted to remove the neighbors here, and we should check. Yes, that is looking better. Okay, that is looking better. So now we have exactly what we want. So see, like just a small mistake is costing so much time. Now we're going to be going through each element and counting the truths. So here we need to get the values. So in the end here we count active cubes. Let sum equal 0. We do let cubes equal map dot values, and then we do a for of cube of cubes if cube, then sum plus plus, and here we can log finally the sum, which will give us the list of all active cubes. Here I can remove these console logs. Let's just check this out, you know. Here this is 11 cubes on the second run. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. So we're good. Let's go up to 6 cycles now. 112, and this is exactly what we were expecting here. So we're going to get the full puzzle input. It looks a bit bigger, which means it's going to take more time to compute. It's fine. Hopefully it's not too much time. Oh, it's a bit slow, you know. A bit slow already. Let's check. And this is good. Let's go to part 2. I'm gonna read that quickly. Okay, this is really fun because basically this is exactly the same problem except we have 4 dimensions now, which is upping a little bit the complexity because we have 1 more dimension, so everything is going to be slower, and I believe my algorithm isn't really optimized, so it's going to be a bit challenging. But you know what? That's part of the challenge, you know. And we're going to go back to the small input because here in that case it's going to gonna be funky. So this is 3D. I think we're gonna take the same. In that case, it would have been great to have like some kind of a map here. I think, you know what, we're gonna make everything 4D except for the first loop. We're gonna make it work with. We're gonna make it work. That's crazy. That is crazy. Crazy. Because here we're gonna basically need to make another for loop. So instead of K here, we need L between W minus 1. L is that and L here. Wow, that's gonna be insane. This is gonna be insane. So here we just have to say or L is not W. Here we have to add L to this, and other than that I think the get neighbors doesn't change. And I think that's it. Here we're going to basically just add the two variables with W here. Oh wait, max and min. We have to add min W. Min W and max W here. Yeah, that's better. So here we have to do the same. I'm a bit scared, to be honest, because here I'm just adapting the code to 4 dimensions. Oh, here we need to add comma W here. And here this is more than, wait, what? Just take this one. So it's W is more than max W. In that case, max W equal W. This is it. And here we need another loop. And W equal minus W. So here we make sure we have W everywhere. Here get neighbors, we have to add W. Here key, we have to add W. And I think this is gonna still work. Or maybe I've broken part 1, sorry. Let's check what happens for part 1. Oof, unexpected end of input. So that's parentheses that I forgot to close somewhere. I guess here, that must be here. Oops, must be here. Unexpected end of input. Okay, so here this is taking a long time. I think here we're doing the thing in 4D already. So that's the correct answer. That's the correct answer. So basically this is working. One thing that I'd like to do is to const part 2 true. Let's put that to false for now. Basically this is going to be the boolean to choose if we're doing part 2 or part 1, and here we're going to say if not part 2, then W L equal W. So here we make sure we stay in the same dimension. So here if we do that, although we're computing in in kind of 40, this should always make a mistake. You know what? I think this is just gonna be we're gonna just modify the code and use that for part 2. There won't be any part 1 code inside the repository, and I think that's fine. So 848, that is the correct answer for the small input. Now we're gonna take the bigger input. I'm afraid this is gonna take so long. Let's just check right now. So this is taking too much time. We're gonna have to just switch the algorithm and improve. Oh, I thought we could hit some performance issue, but it looks like the input is small enough for us to make it work. And this is it. This is it for today. Thank you very much for following this series. If you like that, please drop a like, and if you don't like, please still drop a like. It really helps. And thank you so much. Please subscribe, comment, and see you in the next one. Bye bye.